Who are you?
Hey, hi. We are Team Andromeda, and I'm Abhiram, and I'm an ML engineer.
I'm Jishnu and I'm working on the hardware aspect and the embedded aspect on the project.
I'm Mithilesh. I work on hardware, 3D design, and all the firmware.
Okay, so this is our team. And yeah, here's our what we built. So what we are trying to build is pretty much targeted to the small scale and the medium scale industries which want to try and get into like circuit or PCB testing. So in brief, what it does is like trying to identify defects such as like an open circuit, or if there is a open diode or an open capacitor, any electrical component which might be faulty in a very complex circuit. Right now, it requires a human tester to validate it before it goes on to the actual customer. So the large scale industries get like through it by building huge machines which do the same thing, but also like very deterministic. They don't like they have a workflow of their own, but it's too expensive for the small scale industries to do it. So that is what we are trying to solve here. And
So what's happening over here is this is a test PCB that we made with all the test contacts over here. So the commercial availability of FPT, which is flying probe testing, only gives you a connectivity test. That is whether a trace is connected between two different points. But what the novelties over here is we can actually power the PCB and test all the protocols that are being sent in the PCB and all the signals and the signal integrities. And the biggest thing over here is there's no cameras involved. The functioning of this is completely dependent upon the schematic and the PCB files that you upload onto our AI model. And based on that model, based on the schematic and the PCB files, it understands where all the test pads are. It gets those coordinates, and inverse kinematics takes care of the movement of the both robotic arms, and they probe onto the pads and they take the readings and they give it back to the AIML model. So what happens is there are four main servos which take care of the inverse kinematics. There's an MG995 high torque servos, and there are these SG90 probing servos, and there's a rack and pinion mechanism that just takes the probe down and up. And we are using a Glyph C6 for data collection and inverse kinematics implementation.